Hello everybody. Today's video is going to be for our week 1, day 3 explain about speed, velocity, and acceleration. First thing I'd like you to do in your lab notebook is I would like you to open to a new page, and on the top of the page I'd like you to write day 3 explain. Then I'd like you to split your page into 3 sections. The first section is going to be for speed. Give yourself some room. The second section is for velocity. Give yourself some room. And the third section is for acceleration. As we go through the video, there's going to be some things I want you to write down into each of these sections. And there's also going to be some practice problems that we're going to practice calculating speed, velocity, and acceleration. So I would like you to pause the video and restart it when everybody has their paper divided into 3 sections, 1 for speed, 1 for velocity, and 1 for acceleration. When we talk about speed, what we're talking about is how fast an object is moving. How fast an object is moving. This is an idea that you should be familiar with. You've all either driven a car or rode in one, and you know that how fast you go is your speed. To solve for speed, speed is equal to the distance you traveled divided by the time it took for you to travel that far. Usually when we are measuring distance using metric system, we measure in meters, and when we measure time in seconds. So when you divide distance by time, you also need to divide the labels that you use to measure them. So when we're dividing distance by time, we usually get a unit or a label for our answer that would be meter per second. One tool I like to use when we're doing these kind of physics math problems and we're using a equation that has 3 variables like speed, distance, and time, I like to use one of these triangles to help me set up and solve for different variables. So this is kind of the magic physics triangle, and whatever your 3 variables are, you'd plug them into the triangle. So for speed, speed is equal to distance divided by time. When you cross the lines here, you would divide. When you cross this central line, you would multiply. So if I was going to solve for speed, what I would do is I would cover up speed, and I'd end up taking distance divided by time. If I needed to solve for a different thing in the triangle, let's say I wanted to solve for distance, I'd cover up distance, and I'd take speed times time. So this triangle can be a really, really helpful tool when we're solving these kind of math physics problems. This would be a good time to pause the video and make sure you have this information written into your notebook for your speed section. So we're going to solve one of these problems. So we just want to remind ourselves that speed is equal to distance divided by time, or if we're using the triangle, speed, distance, time. This problem says, what is the speed of a train that travels 132 meters in 18 seconds. We are looking for speed, and to find speed we will have to find distance and time. If I reread the problem, I see 132 meters. That's how far we traveled. That is our distance, 132 meters. 18 seconds is a measurement of time. We did that in 18 seconds. We don't know what the speed was. So I'm going to take my triangle and I'm going to take distance divided by time. So 132 meters divided by 18 seconds gives me, if I took 132 divided by 18, put it in a calculator, it would tell me that that is 7.3. I'll divide the numbers. I also have to divide the labels, and when I do that I get meters per second. That train is traveling at a speed of 7.3 meters per second. Velocity is different from time because velocity measures both speed and direction. Earlier in the week you were looking at the word vector. And a vector is just a measurement that includes the direction of travel. So the only difference between speed and velocity is that velocity tells you not only how fast you're going, but also in which direction you're going. Velocity and speed are calculated in the exact same way. Velocity is equal to distance over time. When you label, or you have your units for velocity, you're going to divide your labels just like we did for speed. So often it turns out to be meters per second. But then you're going to have to add some sort of direction word. So ways you could measure direction are like to the left. Or maybe you would have meters per second up. Some word that tells me which direction my object is moving. The other thing about velocity, since it's a vector measurement, sometimes positive and negative numbers are assigned to numbers to show direction. So positive and negative can be assigned to numbers to show direction. A common example of that is often when something moves to the right, it will be positive, whereas if it moves to the left, it would be negative. There's no set rule about if it moves to the right, it's positive, if it moves to the left, it's negative. It's just, these numbers are assigned, and as long as you're consistent when you're working out these numbers and you keep your positives and negatives the same, that will account for the direction that you're traveling in. So make sure you have this down on your paper. If you need to pause the video, you can. We're going to try one of these velocity problems on the next slide. Okay, so for this problem it says, what is the velocity of a swimmer that swims 110 meters towards the shore in 72 seconds? So the question is asking about our velocity. So we're going to need to find the velocity. And to do that, we need to find the distance that they traveled and the time it took them. If I go and reread the problem, I see that I have 110 meters. Meters is always a measurement of distance, 110 meters. I also have 72 seconds. 72 seconds is going to be a measurement of time. I don't know the velocity, so I'll have to take either my triangle or my formula and just say velocity is equal to the distance divided by the time. And when I take 110 divided by 72, I get 1.5. When I take meters divided by seconds, I get meters per second. Velocity measures the speed, and it also measures the direction. So for this 1.5 meters per second, I also have to say which direction it's going. The problem tells me that it's towards the shore.